Welcome everyone to this new webinar from Amatec, understanding RF capacitance. I'll try that again. RF capacitance technology and its pivotal role in revolutionizing water cut measurement. In this webinar, we're considering the substantial benefits of integrated RF capacitance in your operations, and also its unparalleled accuracy in water cut management to ensure its robust performance under the most demanding conditions. I think this presentation will be quite engaging and of great interest to many of you. We're also going to learn about how this technology not only enhances operational efficiency, but also aligns perfectly with economic sensibilities, offering a proven return on investment that makes an unrivaled choice for industry leaders. Now, our speaker today is Sunny Singh. Sunny is a product manager at Drexel Brook, which is part of the Amatec Level Management Solutions. His career began right out of college, and he joined Drexel Brook as an application engineer. Had the position for 5 years. A few years ago, I returned to Amatec in the role of product manager, where he's now responsible for driving new product development and overseeing support for commercial products. His work is integral to maintaining Drexel Brook's commitment to innovation and quality in level management solutions. Well, welcome, Sunny.
Thanks for having me.
Well, thanks for joining us today. I think this one is particularly engaging. Looking at the deck before we sort of kicked off, and I think some of this, I think a lot of this material will be very interesting for our guests today. So again, I'd like to thank yourself for joining us, but also I'd like to thank everyone for coming along today and spending some time with us. What I'd like to say to everyone that has attended, many thanks, of course, for joining us, but also if you do have any questions, you'll see in the interface in front of you that you can ask a question. As we go through Sunny's presentation, if you do have a question, maybe related to a particular slide, or something maybe wider than the slide that Sunny's talking about. If you do have a question, then please do put that into the chat box, and I'll see that question. If you'd like to, you can come along and ask Sunny directly, or I can ask the question for you, which is entirely up to you. But I would impress on everyone as we go. This is an interactive presentation today, so if you do have any questions, then please do put those into the question box, and I'll endeavour to grill Sunny about anything that you feel you need more detail on. So that's the introduction, guys. So I'd like to hand over to Sunny. Sunny, the stage is yours.
All right, thank you. As Guy had mentioned, we'll be going over understanding RF capacitance technology in specifics to the water cut meter. Let's see if this slide's working. There we go. So as you had mentioned, my name is Sunny Singh. I am the product manager for Drexel Brook branded products within Amatec Level Measurement Solutions. Been back with the company for about 8 months now, but I have a lot of experience on the technical side of things as I was an applications engineer. So a few housekeeping rules. Just please keep your microphones muted or turn off your camera during the duration of the presentation. And to Guy's point, if you have any questions, feel free to pop in, ask a question. We can have a discussion. We'll also have some Q&A at the end of the webinar. So I'll do my best to answer any questions that we have. If for any reason I can't answer them right away, I'm sure we can send out an email blast of some sort to solidify those questions. The session is being recorded and the slides will be provided via email. Okay. So first and foremost, what is a water cut meter? In some cases, you'll hear it in a couple names: water cut meter, water cut monitor. Some people just abbreviate it WCM. In other parts of the world, it's known as a BSNW meter, or sometimes referred to as a basic sediment and water meter. So what it's designed for is being able to detect the amount of water within oil. So primarily used in the oil and gas industry. Customers, when they're doing custody transfer of oil, large loads, especially on lac skids, they want to know how much water is in the oil, primarily because when you're selling oil, you don't want to pay for the water. You want to pay for the oil, sure. Right? So basically, water cut meters are designed to give you a percentage output of how much water, and they subtract that from the net oil. And ultimately, the customer or wherever they're transferring it to, they're only going to end up paying for the oil. So it becomes a very crucial measurement in the oil and gas industry. Also for the refining process, when they're pulling crude out of the ground going into the refinery. They don't want water in the process. So it really helps to determine how much water is being removed. A couple installation examples, and these are specific to the Drexelberg product line. We offer inline spool piece designs and insertion style probes. Now, the insertion style can be a little bit different. We're typically installed in an elbow or a pipe of some sort, or also in larger transfer pipes. So minimum, we go into 2-inch pipes, and then we can go from there. The sky's the limit. But on average, most of our installations are going to be in the 2 to 6-inch realm. Right. So now, if you're familiar with RF capacitance, there's not going to be a ton of theory in this webinar in terms of how RF capacitance works, but basically that's our theory of operation. There's a lot of competitors out there, a lot of different technologies, microwave, infrared. There's also nuclear and a couple others, but Drexelberg has found its niche in RF capacitance technology. So things that can affect our measurement are changing material properties like the dielectric constant, distance to ground, because we are essentially creating in that pipe a capacitor between the probe and the pipe wall. So the length of the probe, changing material properties again, it is an electrical measurement rather than a physical measurement compared to, let's say, TDR, radar, or some of the other technologies out there. Temperature swings can affect this, and basically any shift in dielectric. Now, we'll talk a little bit about, as we go into some of the slides, how we combat these issues and how Drexelberg makes an offering to handle some of these changes. So just for anyone who is unfamiliar with RF capacitance, again, we're creating our own capacitor. For anyone who is unfamiliar with a capacitor, I'm sure everyone knows at this point, it's an electrical device, or electrical component rather, that stores an electrical charge. We measure our capacitance is measured in farads. Now, our measurements are very, very, very small. So we measure to 10 to the negative 12, so in picofarads, a very small, finite, sensitive measurement. So just as an example, to give you a range of what some of the dielectrics look like, water is typically around 80, air is around 1, and most of the oils that we see are probably in the 1.5 to 2.3 dielectric range. And the premise of our measurement is we're able to see the difference the water makes within the oil. Water is going to be conductive. It has a high dielectric. So as you start introducing water into oil, it's going to affect the measurement and the dielectric change, and the unit is able to see that. Right. So just a little illustration. On the left, you have what is electrically a capacitor, and on the right is what we're creating. Typically now, that image there is shown more for our continuous level transmitters, a probe in the tank, metallic tank, and the dielectric being the medium that we're measuring. When we translate that over to a cup monitor, the theory is still the same, but now it's in a pipe. The probe is still one conductive plate, the pipe wall is another. The oil in there is going to be another dielectric, but one of our rules is, and you'll hear me say it a couple times throughout the presentation, is the pipe needs to remain full. And then as we start introducing water, the dielectric changes, the unit sees that change, and then we can output to a % water measurement. So a couple things, again, that affect capacitance. Changing the dielectric constant, typically we can't change it. It's really up to the customer and whatever is in the field. So we have to come up with ways to combat that. Area of the plates, now we can't tell the customer, hey, change your pipe size or diameter. So we're able to modify our probes to be able to make that measurement. And also you can move closer to the tank wall. Now there's a couple different options. You can move closer to the tank wall, or you can make the probe longer. For us, typically, since we're installing in the center of a pipe, we opt to make the probe longer. And again, I don't expect anyone to do this math because I don't do it on a regular basis, but just to kind of show where the actual calculation is coming from, capacitance equal to the dielectric times the area of the plates divided by the diameter of the distance between the plates, sorry. So again, I don't think anyone nowadays, even our competitors, really does the calculation very often. It's mostly an engineering tool. Occasionally we get into it, but the cup monitor, we've offered it for a number of years now. We've got it down pretty well to a known science. So this is just more for educational purpose on what's behind the scenes.
Yep.
So again, the electrical properties, it's going to be dielectric constant primarily and electrical conductivity. As those things change, Now, conductivity, not so much. It's primarily the dielectric content with our instruments. As those things change, it's going to affect our measurement. Again, water, high dielectric, oil, low dielectric. So the cup monitor, again, is looking for that high change in dielectric as we start introducing water. And the unit, because we're measuring 10 to the negative 12, again, in picofarads, it has enough sensitivity to pick up small amounts of water. We could go as low as about 0.5% of water.
Okay, I was about to ask you that, how sensitive the actual probe is when the water is introduced. But if that's the level of sensitivity, then the probe will see the water very, very quickly.
Yes, exactly. So we have different capacitance ranges going, and there are set ranges within the units, and we'll talk about that in the product offering. But basically, a lot of our customers, especially in the US, measure down to about 0.5%, sometimes 1% water. So we can go lower than 1% water.
Yep.
Now, this is, again, a little bit more theory. What we're doing inside our unit. Again, this applies to our continuous level transmitters, and the next slide will show what happens with a cup monitor. Basically, we have a certain amount of capacitance being generated either in an empty tank, and as liquid level rises, capacitance changes, and we're able to make a linear interpolation to level that is seen in inches, feet, or even in metric units that we have options for. And then on the output side to the DCS, PLC, or other controller, we're sending a 4 to 20 signal. For a cup monitor, it works the same way. There's an empty pipe, you're seeing a certain amount of capacitance. When you introduce a full pipe of oil, that's another capacitance. And then as you start introducing water, capacitance increases. And that's what we translate again to a 0 to 5%, 0 to 10%, some percentage of water, and a 4 to 20 output.
So in effect then, 0% water, that's your baseline.
That's correct. So the baseline is the capacitance that's generated in an empty pipe. And then we're also, and this is one of the reasons why we tell our customers the pipe needs to remain full. We have a calibration that's set from the factory as 15 picofarads or 30 picofarads in full oil, and we make our measurement from there.
I'm with you, sure.
Right, so things that can affect the measurement. In train gas, gas can introduce system inaccuracies or negative readings. Causes gas can come from petroleum vapors, steam, natural gas. We see them a lot in larger pipe diameters or where there's a pressure drop. And usually the solution is a customer supplied degasser, especially for cases where you're going above 10% water. Now in train gas, it really is more on the customer side to be able to handle that because we can't change the customer's process. So we usually recommend a degasser. Other things that can affect it are, well, salinity is a question that we get a lot. Now, salinity doesn't affect us. Luckily, because whether you add salt or remove it, the fluid, the water is still going to remain conductive. So we're not affected by that measurement or by the percent of salinity. So Coat Shield. If anyone is familiar with our point level technologies, we offer something called Coat Shield. That allows us to ignore conductive coatings. Now, in the cup monitor, most of the measurement is going to be insulating, but the Coat Shield plays a crucial role in providing some electrical stability when you're starting to get into the higher water cut ranges or if there's paraffin buildup. And another reason why it's there is because our probes are built with layered materials of PEEK, insulators, and also metal. It also provides some rigidity and when you get to some of those higher flow rates.
Okay.
So product review, we offer a couple different products. So we have, I believe, 1, 2, 3, about 4 or 5 different products within the cup monitor family. They all fall under the Universal 5 cup monitor, which is also, there's also a level transmitter variant as well as a cup monitor variant. Okay. The primary differences is they're both capacitance technologies. The only difference is the output is going to be percent water versus feet, inches for or some other measurement for level. All of our probes, so we do offer probes that go up to 450 F. I apologize for the non-Celsius translation there. And then probe options up to 1500 PSI. Power supply, typical loop power, minimum of 16 volts. I know this slide currently says FM and FMC approvals, but luckily in the next few days, we actually just sent out the notification today. We'll be offering ATEX and ICX worldwide approvals on the entire Universal 5 product line. As far as the water cut goes, this is where it gets a little tricky, is depending on whether it's heavy oil or light oil, we can do 0 to 50% or 0 to 80% water cut. And the unit has some set ranges. You can set it for 0 to 1, 0 to 5, 0 to 10, etc., to help kind of maximize the accuracy and resolution within that range. All of our cut monitors use the probe that you see, which is an injection molded peak design. So they're not just simply layered, they are injection molded from the factory. It's an insertion style probe offered with integral electronics. It is HART compatible. Using our homegrown software Heartwind, or if you're using a HART 475 communicator, and minimum 2-inch pipe size for installation.
Yep.
Next up, we have the Universal 5 cut monitor with temperature compensation. So same design, virtually the same electronics as the previous product. The only difference here is now we've added an embedded temperature sensor inside the probe. There's an RTD that has a hollow tube inside the probe. Now, the reason that's there is we talked about temperature swings can affect the dielectric constant.
Yep.
So especially in cold months where the temperature swing, or if they're pulling crude from different areas, you're going to see different temperatures. So we're able to compensate with that temperature sensor. We're able to, up to about 160 degrees F, we can modify and provide a corrected water cut within the electronics. So this is great for those customers who are seeing a lot of different temperature swings, and they have an option to be able to compensate for it. Or some customers will have a temperature sensor somewhere else in the line, and then they'll compensate within their PLC or DCS. So we're providing it all in one package here.
Oh, see. So you've with this kind of sensor package, then it's the ultimate in flexibility. You haven't got to put the temperature sensor actually on the cut monitor itself. It could be elsewhere if that's the way your process is set up.
Correct. Some customers do that as well.
Yeah.
Right. This takes that guesswork out. You have less instrumentation, less things to manage. So probe options. Now, you'll probably see a couple different probes as we go through the cut monitor line. So we design our probes to take all the guesswork out for the customer. Customers don't have to come to us and say, hey, we need a 36-inch probe, we need a 24-inch. We define what that is. And going back to how sensitive the measurement is, and we're creating, again, a capacitor within that pipe wall, we need to generate a certain amount. That's where our calibration point starts. So what we do is we have set probe lengths based on the pipe diameter. So in our data sheets and our manuals, when you go through and make your product selection, all you have to really tell us is, hey, I have a 3-inch pipe.
Yeah.
What probe do I need? And we have set lengths for that to be able to make that measurement. And what you're seeing here is also process related, is our standard peak probe that typically gets installed in any pipes that are 8 inches or less than 8 inches, sorry. Same with the middle probe. Now, the difference is the middle probe, it has a welded collar to be able to handle higher pressures. Okay. And then when you go into the larger probes that are greater than 8 inches, once you're greater than 8 inches, it doesn't matter with the pipe diameter, because we offer a concentric shield that goes around the probe. Now, what that does is we've created our own capacitor. We don't care what pipe size you have. We're making that electrical measurement within that probe instead.
Yeah. So again, that's the flexibility of the system. That if you do have a pipe and you're asking the question, well, is that not going to be an issue to actually create the capacitors? Well, no, because if we go into those kind of pipe diameters, it doesn't matter, because we've already covered that with the peak probe because of the shielding.
Yep, exactly. Right. Yeah. And there's even a cutout in that probe, and we'll see how that gets installed. But that cutout allows for flow to go in and out of the probe.
Gotcha. Yep.
Right. So a couple of the benefits that we see with our probe specifically is we don't use Teflon, we don't use PFA, we don't use any of these other, we don't use any epoxy. There's no coatings on the probe. It is just bare stainless steel. We do have some other options depending on what you're looking for that go into more of a custom offering, but our peak, it's a glass-filled peak design that we have. So unlike some of our competitors, we've never seen any cracking or erosion or degradation of the coating for some of our competitors that are using epoxy coating. So one thing that's really nice as a selling point is, in addition to our competitive pricing is that you have minimal maintenance. You don't need to pull these probes out constantly, clean them off, or get them repaired.
So it is. It's if you go down this route, it is almost an install and forget. It really is. It's like,
yep,
you're done.
The ideal installation, that's exactly what's going to happen. You install it, you just leave it alone.
Okay.
Right. So a couple installation rules. Some of these we've already talked about. The pipe needs to remain full. On the right, you're going to see a typical installation. We like being installed within the flow or opposing the direction, and there's a couple of reasons for this. A lot of our competitors can't seem to do it. They usually want to go within the flow. We found that being opposed to the flow is ideal for us because it also, if you have paraffin buildup or any coating, it helps help self-clean the probe off. It also helps minimize some of the vibration that we're seeing. The probe essentially self-centers itself. Now, the probe itself, let's say that pipe was upside down, the probe can be installed in any orientation. It's not like certain technology, let's say with level, like TDR or guided wave radar, where you have to be in a top-down approach. So if this pipe was completely upside down, it doesn't matter. As long as the probe is opposing the direction of flow, the orientation of the actual system doesn't matter.
Okay.
Another thing to note is oil and water within the flow can't separate. So let's say the flow were to stop, oil and water, different densities, so they're going to separate where you have oil on top and water at the bottom. That can't happen in this installation. If that were to happen, the water is electrically conductive enough where it's going to short out our metal probe to ground, and you're going to read high. So the fluid needs to be emulsified. It needs to be moving to be able to detect those fine changes. Once you get up a certain rate, if it separates, you're going to see that. And that is true of any capacitance technology. So now when you get to pipe sizes that are greater than 8 inches, this is where our concentric shield probe. Same installation rules. Now, the only difference is you have this concentric shield, and you'll see in that little cutout there that's zoomed in, that's where our cutout is. Now, we mark on our probes where that cutout is. So whether you have a flange or an NPT, it'll give customers an idea of what the orientation should be. The reason the cutout's there is, again, because we like being opposed, the flow will go up, and also that opening will allow for release for the flow, so you're not blocking anything. It also prevents paraffin buildup inside that concentric shield. Again, a self-cleaning design, minimal maintenance. For larger than greater or greater than 16 inches, it's even easier. So we like to be installed roughly at a 45-degree angle opposing the direction of flow. The pipe diameter is large enough so you can just go right across. And then again, note the cutout within the concentric shield. You're opposing the direction as flow goes up. It's going through that hole and continuing on. But the same rules apply. The pipe needs to be full. Fluid can't separate. It needs to be moving. Right. So this is just a screenshot of our Heartwind configuration. Now, I know sometimes customers aren't a fan of proprietary software, but I guarantee you this is, even with my experience with using Pactware, Hart 475 computers, and some other ones, this is a really, really easy to use tool. It works with wireless Hart, not wireless Hart protocol, wireless Hart modems, more specifically. So hooking up to a PC, some type of PC-based tablet, you can hook up. It's very easy to use. You don't even have, there's no DTM installation. It's a free download. So you hook onto your Hart leads, open up Heartwind. It'll auto detect what instrument is connected to it. It's a software that we use for almost all of our products. What I like about it the most is that I don't have to tell it I have a universal 5-cut monitor, I have a universal 4, I have an ultrasonic. It automatically detects what instrument you have and will pull up the configuration. As you can see, it's a very limited scope interface. It only gives the customers what they need. There's not a lot of extra fluff. That's always been my challenge with Pactware. While it's a great tool, it has a lot. Sometimes it can be overwhelming, especially for an instrument tech that has 50, 100 plus instruments from multiple manufacturers to manage. I like Heartwind because it's simple and easy to use. We tried to take all the fluff out, make it simple, make it realistic. No need for a Hart 475, and again, no DTMs to manage.
Yeah, because they used to call that plug and play back in the day. And
yeah, exactly.
That's kind of what it is. Plug it in and it plays. Off it goes.
Yeah. I understand the aversion to having proprietary software. Hey, now this competitor has this, but now I've always been of the mindset, if it's easy to use, makes the job easier, then okay. So now another one. Now this is still a cup monitor. The only difference is we've changed the probe design. So the electronics are still the same.
Mhm.
The approvals are still the same. All that's the same. The only thing is now we've made an inline spool piece design. We've taken the injection molded peak probe and basically extrapolated and made a spool piece. So this is meant for inline installations. A couple limitations. We have dropped down to a 30% water cut. Currently, it's only available with FM and FMC approvals, but everything else is virtually the same. 2 inches going up to 4 inches. If you have a larger pipe size, depending on the opportunity, we could take a look at it. And the nice thing is we do offer it in carbon steel as well, in addition to 316. So the nice thing about this one is it's bidirectional. It doesn't matter. It's not like a flow meter. It's so that is the one thing to keep in mind. It's not a flow meter. It's not a NetOil computer. But with the way it's designed, it can be installed in any orientation. It can be installed vertically, at an angle, and it doesn't matter which orientation. So if an instrument tech says, "Oh, I installed this way, I'm supposed to be that way," it doesn't matter. It's bidirectional. There's nothing in there that says it's looking for a certain direction.
Yeah.
You just pop it in inline, set it and forget it. And the inside of the probes, if you look at the cutaway, it's still our peak probe. We just changed the design a little bit.
Hmm. Yeah.
And the last one, so this isn't necessarily a cup monitor, but it's an add-on. The little unit that you see in the upper right there is what we call our density compensation module. So what that allows us to do is for customers that are pulling crude from different areas or different tank or different truck unloading, and they're seeing shifts in density in real time, or they don't want to have to recalibrate. Typically, competitors, or even if you get a standard cup monitor, every time the crude changes, you need to recalibrate and say, hey, this is the new batch that we're getting. So we offer a solution where this is an add-on module that can either be purchased with a cup monitor from the factory, or if you have an existing cup monitor in the field, we can add this DCM, density compensation module. And what it'll do is the cup monitor provides a capacitance measurement that feeds into the DCM, and the DCM will also take in the density reading from a customer supplied Coriolis meter, regardless of manufacturer. And it's basically a little computer, so it reads via Modbus. It's going to act as essentially our own little master, and it's going to pull in the capacitance information from our cup monitor, and the temperature and the flow rate and all that stuff from the Coriolis meter, and then do a corrected output for what the water cut should be. Density is also going to affect the dielectric constant that can affect the overall net oil percentage. So that's what the DCM is meant for. And the beauty of it, it's a small package, it's really affordable, and you can add it on to any cup monitor. It's not like you have to replace the whole system if you need to.
Yeah. I like the idea that you can augment an existing system without, without making root and branch changes, because no one wants to do that on what could be a very complex process.
Yep, exactly. And the reason I like it is just the fact that you can just add on. If you don't know if you need a DCM or you want to think about it later, or if your process has changed, you can add it on later. You don't have to rip out the cup monitor that's in the process itself. You're just adding essentially a little calculator to the process.
Yeah, indeed. So you see that a lot. You see that existing processes often they can kind of change slightly or even radically. Then what do? Well, you can still leave all the cut monitor in place and then just add on whatever you need to. Yeah, that's the beauty of the system.
Yep, exactly. And because it's Modbus, there's compatibility with virtually any PLC. Like as long as you have Modbus communications, and if you have a Coriolis meter, you probably do, or something on site that does it. So it'll just pull in all the data. It can be set as a master or a slave unit to the PLC.
Indeed.
All right. So now the DCM, just because of how it offers a breadth of more features, because of its Modbus communications, we do use a different software for it called ST Explorer. Again, it's also a free download. The interface is a little bit more complex than Heartwind, again, because of Modbus, but it just walks you through all the registers and everything that needs to be configured. Again, free download from our website. And then having a Modbus expert on site and within any Modbus installation for any manufacturer is always helpful. So this is just to kind of show in our Horsham, Pennsylvania facility here in the States, what kind of research and testing that we do with cup monitors. We actually have an entire cup monitor rig set up at our facility. Basically, we're able to test customer crude. So we worked with a couple oil manufacturers here in the US where, hey, we're having some trouble with our measurement. We're not sure how to do the calibration. We
Mm.
have the ability to accept crude from different parts of the world. If customers are willing to ship it, we could put it in our test lab and run through different scenarios, shift the temperature up and down, change the densities. And you can see there we have multiple cup monitors in different installations and just run through real life scenarios.
Well,
We're not,
that's amazingly
not
useful, isn't it? I mean, do you often are you often asked to, I guess, when it's a customer is looking at maybe a new process, or as I said, modifying an existing one, we're going to take in maybe a different kind of oil to the process. Can you help us to look at that, look at the calibration before we even go forward with the cup monitors?
Yep, exactly. And this brings it from
Yeah,
engineering theoretical, what we're seeing in our code, what we're simulating to, hey, let's actually put it in the process and see what
let's
happens.
actually try for real. Yeah, yeah.
So it's equipped with like an 8-gallon drum there. We can pump crude through, we can pump water. There's a heater in there, a cooler. We can run through virtually any scenario.
Yeah, yeah.
So just a close-up view of our setup here. And then a couple applications. So the most common for us is going to be the lac skid, where we're doing custody transfer,
Yeah.
pipeline loading and unloading is another one, dehydration equipment. And the ones you see in red are a little bit outside or mostly outside of the oil and gas industry that we'll talk about. So in recent years, we've kind of seen other applications where we can use the RF capacitance technology and apply the cup monitor in other areas, which is really cool. So lac skids are probably going to be the biggest for us. Uh, Separation tanks is another one because of our high accuracy, lower cost, and low maintenance, minimal cleaning, no pulling it apart. Our spool piece designs, we've actually been able to displace one of our competitors because it was a drop-in replacement, so
Yeah.
the customers didn't need to modify any of their piping, no welding. Um, we have a live measurement, so the refresh rate is very quick. It can go to the PLC, and you can see real live measurement data. And the calibration is also simple. It's a 1 point calibration. You're not having to do a high and low calibration like you typically see with level measurements. It's a 1 point calibration. So even when you are changing different crudes, it's a simple just 1 point. You do your grind out. You say, hey, this is the percentage that we have, and you're good to go. Storage tanks is another one. Uh, we've had some competitors where some of the, or sorry, customers where some of their competitors, the technology was drifting by a certain amount. We've never had any issues with our probes failing, degrading, or also any drifting. So one thing that we're able to do is because of the corrosion that this customer was seeing, they had to constantly pull the units, clean them off,
Yeah.
and put it back in, or we'd even have to send them back to the manufacturer to get repaired or get recoded, and that was costing them 150K in US dollars every year to just fix that. So we were able to displace them, no maintenance at all, and they were able to get their payback within 2 years.
Yeah.
Pipeline, again, custody transfer. Another place that it's really useful. Now, this is kind of an off the cuff application, but it comes down to how versatile capacitance can be. So sometimes you'll get what's called a water slug in the pipeline. And if it hits our probe, now, again, we talk about how the water and oil can't separate. So if you get a water slug in there, it's going to short out our probe and then read high. Now, sometimes customers see that as, hey, we don't want that happening, but here's the advantage. You know that there's a water slug coming and you can react to it,
Yeah.
or see that, hey, this is going to affect the instrumentation, what's going on. Now, some of our competitors, what will happen is they'll just see the water slug, the unit will peg high and then stay there, and then they have to reset everything. Our unit, once the water slug is gone, it will actually refresh. So once it stabilizes, it'll say, okay, I'm back, I'm running again. But the nice thing is because the probe will short out, it'll peg to 22 mils. You can use it as a water slug detector and say, okay, there's a water slug in there. That's the only time it shorts out. We just saw like a huge chunk of water come through.
But that's the power of the system, isn't it? Because once the slug has gone through, it's a reset. It's not a case of the actual device is destroyed or it's just not useful anymore. Do you see on the software end? You see you actually see the slug itself. You see that's an alert. Let's look at that. Let's keep an eye on that. What is that? If it goes away, it's probably a slug, and then the whole system then goes back to baseline and off and it carries on.
it'll go on. It won't just stay there and get stuck when there's an alarm or
Yeah.
something went out. It'll reset once the error is okay.
Yeah.
So distribution centers is another area. And again, the application is, or what I would say is the process application is virtually identical. You know, it's going to be water within oil, but these are going to be locations. So lac skids, distribution centers, loading and unloading. Now getting into, that image didn't come out super well, but we'll do the best we can here. Another installation that we've kind of seen that was really interesting is a monomer chemical plant. Now this isn't oil and gas at all. This is engine oil and water. So this is more on the refined product side in a monomer plant. Now, the reason why these are interesting is because you have to look at how capacitance technology works. At the end of the day, the unit is an electronic sensor. It's a dumb unit. It doesn't know whether it's oil or whether it's water. All it's seeing is that there's something conductive inside something that's insulating. So theoretically, as long as you have those rules in play, the unit will still work. So in this case, it's engine oil and water. It doesn't know that it's not crude. It doesn't know any of that. It just sees engine oil is insulating, water is conductive. And we're going to see that with a few other applications as well. So this is in a much more downstream, hey, the product's already refined in a chemical plant outside of oil and industry, oil and gas. So the rule here is basically if you see an application in a pipeline of some sort, moving material, and they want to be able to detect something conductive inside something insulating, that could potentially be an application for the water cut monitor.
Sure.
Yep. So basically, it was at a steel plant. They were converting coal. Another one was in a tar line. Basically, they wanted to measure the amount of moisture inside of tar. You know, and again, this is another application. You have tar moving through a pipeline, and they wanted to remove the moisture content out of that tar because it affected their quality control. But the premise is still the same. Steel plant outside of oil and gas. You know, you're detecting something conductive and something insulating. Tar is very thick, very insulating. And the nice thing about it, this goes back to coat shield and also that probe. Tar is typically has to be kept at a very high temperature to keep it in liquid form. So our probes can handle that temperature. It can handle the pressure. And it can also handle the coatings that are unaffected by it. But again, I repeat, conductive, inside insulating. So we were able to detect the water and the moisture content within the tar. So completely non-oil and gas. So this is one example where the customer had basically stated is their old sample, what they would do is they would pull a sample, take it to a lab, go through the process, which would take quite a long time. You have to wait for the lab results and then move on. Ours is a real-time, in-process solution, minimal maintenance, and it was accepted by this customer and saved them a lot of time and a lot of money, and also manpower. So the direction
I'm also thinking, food and beverage seems to me to be a really interesting one, particularly beverages. Anybody in that space, this can be quite kind of revolutionary.
So it's a good thing that you brought that up. So I don't have images of it, unfortunately, but we did do an application in the States in the food and beverage industry where milk fats in milk fats, they wanted to pull the moisture content out of milk fat. So it was a dairy plant, and it was again inside of a pipe. You know, milk was flowing through. The only challenge there was we needed a sanitary grade sensor, which we were able to provide. But the premise was the same: water, something conductive, and something insulating. So we were able to detect the moisture, the percent water inside of milk fat.
Well, can I ask about? Obviously, we mentioned a lot that the probe needs a moving fluid. That's how it operates. Is there a level of viscosity that you can handle? I guess that there must be some kind, again, a baseline where there has to be X amount of movement of the material, doesn't matter what it is. So anyone that's maybe listening to this, that say, we're in that kind of space, but our material is quite viscous. It does move, but is it going to move enough for this application?
I think so. I think the bigger thing is we don't have a viscosity spec. Crude can be varying viscosity. We've never seen any issues with thickness. The biggest thing is, even more importantly than it moving, is that it can't separate. That's the point. So the minimum recommendation is it needs to be moving enough so that the material doesn't separate into two phases.
Well, that's a good baseline. So if anyone's listening to this and say, yeah, that's our process, bear that in mind. That if you think this is not going to be applicable, have a think about what you're actually forcing through that pipe. If the separation, it's not the viscosity which I thought it was. It's actually think about the separation aspect.
Yeah. So if it does separate, then that probably wouldn't be a good application. In that case, you're probably better off with one of our point level technologies where it can detect the big change in phase. So we do also point level interface detection where oil rises, and as soon as you get to the water phase, it'll detect. So if you're looking for that type of separation, a point level device is probably going to be better. But if you're looking for real time content, it's got to be a homogeneous solution. So another area that we don't have in this presentation was we did an application for lube protection. Basically, it was machine oil going through pumps and bearings, and as it absorbed the moisture through the atmosphere, through the process, they wanted to make sure that moisture was being pulled out, or they changed their hydraulic oil once it got to a certain percentage, so that it'll protect their pumps, their bearings, and prevent it from rusting out. So again, still I guess oil and gas adjacent, but it was in pumps and bearings, and that could be virtually at any facility.
Yeah, absolutely.
So again, the Drexelbrook advantage is low maintenance. Our probes, in an ideal installation, if it's installed correctly, calibrated correctly, you just set and forget. You shouldn't have to pull them. You shouldn't have to clean them off. Compared to our competitors, we do offer some of the highest pressure ratings, up to 1500 psi and 450 F. Durability, because of the coat shield, because of the injection molded design, we've never seen any of these probes break off in the field. They're not just pressed in and layered. They are injection molded, making them very rigid. We use them all over the world, offering both insertion and spool piece designs with temperature compensation and the DCM. It's a pretty good solution, and you'd be surprised if you get in contact with us, you'll see our pricing is actually pretty competitive.
Yeah, absolutely. I think it's one of those aspects to, I guess, process management. If you're looking to maybe overall something, or you're looking for more accuracy and particularly more agility across your process, this kind of thing could absolutely be for you. Well, thanks for that, Sonny. That was fascinating, really. I think there's a lot of applications there. I'm sure everyone's thinking, how can we use these kind of things in our process? There's a lot of applications there. So we've stepped outside of oil and gas, absolutely. Very few aspects or very few industries where this might not be applicable, I think. Now, we've had a few questions which I'd like to sort of put to you. One thing, in fact, I'm writing on my pad as you were speaking. Pressure. Is the highest pressure rating for the cut monitor that can handle?
It'd be 1500 psi. So we offer a couple different probes that are all injection molded. On average, usually we don't see a lot of applications going above 200 psi, but the maximum with our high pressure option, 1500 psi.
That's your max. Okay. I think you might have mentioned this also. Someone actually mentioned again about the cut monitor and how it handles paraffin buildup. I think you mentioned paraffin somewhere, didn't you?
So power consumption is going to be minimum of 16 volts, going up to 30 volts. So it is a loop powered device that is hard capable.
Okay. And the other point, someone mentioned also, again, I'm not sure if you mentioned it earlier. You were talking about, I think it was some atmospheric impacts on, I think, on the actual probe itself or the pipe, particularly about sort of gas and that kind of ingress. Someone's asked about paraffin and that kind of buildup. If that's an issue for the probe.
No, so paraffin is going to be an insulating coating. Our probes is going to be, I wouldn't say affected, but if anything is going to have an effect, it's going to be a conductive coating. And that's where coat shield comes in. Coat shield is going to ignore conductive coatings. Paraffin buildup, 99% of the time, not a problem. Now, we have seen rare instances where if you have an excessive amount of paraffin, and we've only ever seen this in very, very cold regions, like in northern Canada, where it gets very, very frigid cold and the paraffin can actually solidify. Now, in those applications, we recommend customers having heat tracing on their pipes if they don't already. And that was the one time we did see that issue where there was an excessive amount of paraffin buildup. It was only in the winter months where they had to pull it out and they had no heat tracing on their pipes. But other than that, 99% of the time, not an issue.
Excellent. We've also had another question just pop in from Mark Sykes. Thanks, Mark. He asks, we talked about water slugs. He asks, how long does it take to recover after a slug of water? You talked about the sense of reset. Can you give us an idea of the time frame?
Time frame, usually the longest I've seen it take is about 5 to 6 seconds. Now, it is a very real-time measurement. It also depends on a number of other factors, because now sometimes water slugs, you see a big water slug and move. Sometimes it's more of a fading effect.
Yeah.
So it really is process dependent. But if it's a very quick going up and down, I've seen it within about 3 to 6 seconds. It just comes back.
Okay, thanks. I hope that's answered your question, Mark. Also, I think early on in the presentation, you also talked about, I guess, also the probes and how they're matched to the pipes themselves. Someone asked about the length of the probes themselves. Is it
Okay?
For you guys, it's an off the shelf matched to the pipe diameter, or is it a case that there's a bespoke solution as well?
So it is an off-the-shelf solution. Customers do not need to extend or cut the probes. We really discourage against that. If you cut the probe, extend it, you are going to throw off the baseline company or manufacturer calibration that we send from the factory. So the probe diameters, the probe diameter is a 3/8 inch diameter probe at the tip.
Yeah.
It can be anywhere from 21 inches up to 35 inches, depending on the pipe size. So basically, the larger the pipe diameter, the longer the probe needs to be able to compensate and get that same calibration.
Okay, I'm with you. Amazingly, we've come to the end of our chat, Sonny. I think that's rattled by. That's been a fascinating chat about, I think, a technology which I think a lot of people that have joined us today could absolutely use on a highly practical level to kind of revolutionize what they're doing. If they're looking for a solution in this kind of space, and it's not just oil and gas, absolutely not. I think it's a application that really has a lot of practical use for a lot of people in very diverse industries. Well, everyone, if you'd like to learn more about the water cut itself from Drexelbook, there's a learning zone on their website where you can learn a great deal more in detail. So please do visit www.drexelbook.com/learning zone. There's also a YouTube channel, which is also extremely detailed. A lot of video on there. So if you search for Amatec YouTube channel, you'll be able to see more video about this topic and anything that connects to it as well. Again, I'd like to thank everyone for attending today, and I thank Sonny for presenting. I think it was a very engaging and very interesting presentation with a lot of practical application right across many industries. Again, everyone that's attended today, thanks for taking the time. Until the next time, it's goodbye from me, and it's goodbye from Sonny.
All right, thank you. Take care. Appreciate you having me.
Well, take care, and we'll see everyone again soon.
Cool. Take care, everyone.